So this is function and its notations. Any graph could be parabola, graph could be straight line, a graph could be any. I mean, whether your graph is linear or non-linear doesn't matter. Okay, if any graph is given, f of x is equal to anything, it could be linear graph ax plus b, or it could be non-linear ax squared plus bx plus c. So the first is how to find the intercept. As I told you, when you are looking the x-intercept, what to do? Y is equals to 0, or you can say f of x is equal to 0. When you are looking the y-intercept, what to do? X is equal to 0, right? This is the basics. Yes. In any graph, take an example, let's say f of x is equals to, I'm taking the linear graph 3x minus 1. So whatever we put means x coordinate, that is called domain. Whatever comes out, that is called range. So f of x is equal to 3x minus 1. So what is f of 0?
F of 0 is minus 1.
F of 0 is minus 1. What is f of 1?
It is 2.
What is f of 2?
It is 5.
5. So you can see the value what we are putting, that is the x coordinate, or we can call it as domain. So what is the domain? Whether you say domain or you say x coordinate, both are same. Coordinate. And we are putting here 0. With respect to 0, what is the range? Range is nothing but y coordinate. Y coordinate. So this is coming minus 1. For 1, it is coming 2. For 2, it is coming 5, etc. So these are the respective domain and range.
Yes.
So for this function, if I ask you, what is the all possible domain? What is the all possible range for this function? What could be the all possible domain?
Minus infinity, comma infinity for domain, and same for range.
Yes, because there is no restriction. You can put anything in this, there is no problem. Minus infinity to plus infinity is going to be the domain, and range also could be minus infinity to plus infinity. But in some other questions, you may not find that. Sometimes, there'll be some restricted domain and there'll be some restricted range. Okay. Now, maximum and minimum value of the functions. Okay. So how to know the maximum and minimum value of the functions? That graphically we already understand. If the graph going up, if parabola goes up.
Yes.
Is saying the maximum and minimum value of function can be found by locating the highest and lowest point of the graph respectively. For example, this one, okay, that we already discussed. Max is going to be infinity, and minimum in the graph, whatever the lowest value of the graph, that is the minimum. Whatever is the maximum and lowest is going to be here is minus it. That the concept, we know this one, but we are going to explore it in other way. Okay. Now here is saying increasing and decreasing functions. Okay, so how to know in which interval function is increasing and how to know in which interval function is decreasing. Increasing and decreasing interval of the functions. How we do that, I don't know, have you studied this derivatives like differentiations? Yes, no?
Very minorly in school.
We need very minorly only, we don't need in advance. He's saying the derivative of the function may be used to determine whether the function is decreasing or increasing on any interval of its domain.
Yes.
So I will discuss little about this derivatives. Here I'm telling whatever function is given, you find its first derivative. Equate to greater than 0. I mean, first derivative greater than 0. If you put first derivative greater than 0, so this area function will be increasing. First derivative less than 0, this area function will be decreasing.
Yes.
So let me talk a little bit about derivative. I'm sure you know f of x, let's say, is given x power n. So what is its first derivative? Do you remember a little bit? Let us say f of x is equal to x power n. So what is the first derivative?
X.
N x power n minus 1.
Yes.
So whatever with the power we keep here into x power, just reduce 1 to the power. And so f of x is equal to, if any constant given, c, any constant function, in that case the derivative of f of x is going to be 0. I will take 2-3 examples to understand the derivatives. For derivatives, I'm going to take 3-4 examples, small examples, and we'll understand. Let us say f of x is given 3x squared minus 7x plus 4. So can you tell me what is its first derivative, f of f dash x?
It will probably. I'm not sure.
No problem.
I have.
So what you can do is f dash x of this means f dash. You see the screen? You write completely this one, 3x squared minus 7x plus 4. After then you just distribute this f dash to everything. Okay. And wherever you get the constant, keep aside. So this is 3 times of f of x squared minus 7 times of f of x plus 4 times of, or you can say f of 4. It's a constant term, right? So you can write it like this. So 3b here, and what be the derivative of x squared? I gave the formula, f of x is equals to nx power n minus 1. So what
Yes.
be the derivative of x squared?
N x.
N is
1.
2. X is x power 2 minus 1, right?
Yes.
So this is going to be how much? 6x.
Yes.
Minus 7. Here power is nothing, so we assume 1. So what is going to be this? 1 into x power 1 minus 1. Let me write here. 7. 1 into x power 1 minus 1. So what with this one? X power 0. And x power 0 is 1.
X power 0, yeah, 1.
And this is the constant term, so this one be 0. So finally it's going to be 6x minus 7. Is that clear? This is
what does, but I have like very little experience with this. So like what does the derivative like do?
Yeah, whatever you got this derivative, and if you equate to greater than 0, that reason this function be the increasing. Like if you see here, this is going, I said derivative equate to greater than 0, f dash x greater than 0. So you'll get that area, this function will be increasing. So how we do this one? So when we know the function will increase, so what we got, f derivative x, f derivative, let me write here is f derivative x, we got 6x minus 7 and equate to greater than 0. So what we can say 6 minus 7 greater than 0, reason function will increase. So what is this? 6x be greater than 7. What is x? Greater than 7 by 6. So if the value of x, if you plot the graph, I don't know how graph goes for this. If you plot the graph for this one, wherever the value of x be 7 by 6 or more, that area function will go up. It is increasing region. It is something like, of course, this is the parabola, so I don't know where exactly it's going. So it's something like this here is saying, yeah. So you can see this is the increasing region, right? This could be x equal to 6 by 7 by 6. So from here to anything, it's increasing region. So from this to this region, function will increase.
Yes.
And where is decrease? Huh? This is the more complex equation topic I told you. So it is going. Yes. So we have to little digest the complexity. So f derivative x, wherever is be greater, so this is increasing region, and where is the decreasing? From here, whatever be the below, this is the, you can see function is falling down. The value of it, this is decreasing region.
Yes.
Okay. Let me take 2-3 more examples of derivatives, so I'll be clear that you are clear with the concept of derivatives. No, derivative is a big concept. Probably, complete intermediate, you'll find calculus derivative. But here, I'm just taking very small chunk of that.
Yes.
Here, I'm picking just very small chunk of that. Let's take for more examples of derivative. If I say f of x is equals to x power 7, so what is f dash x?
It is is equal to x to the power of 7. Then it is f1 of x is equal to 7x to the 6th power.
Correct. This is not 1, this is the dash derivative dash. It's not 1. Okay. And one more example, f of x is equal to 7. So what is f dash x?
It is
0. Because this is the constant term.
Yes.
F of x is equals to 5x minus 4. What is f dash x?
5x minus 4. It is 1 to the 5. I'm not.
No, you are sure. See here. I told you, you can separately do this one, f of 5x minus f of 4. So this is the constant, is going to be the 0.
Yes. And yes.
This one be how much?
That would be f of 5x. That would be 5. That would be 5x to the 0 power.
It means basically only 5. X power 0 is 1.
Yes.
Okay. One more example. Let us say f of x is equals to 27x square minus 36x plus 44. Without using pen, can you tell oral?
So it'll be I guess I can't. I'm not sure.
No, you are sure. You do separately. Put this.
Yes.
Put this. Right.
Yeah.
So 27 anyhow is be the outside into x square be 2x power 2 minus 1.
Yes.
Minus 36 be out. And how about x? Or better, you remember f of x, let us say f of x is given x. So f dash x is always 1. Because
Yes.
this can be written as 1 into x power 1 minus 1. 1 into x power 0, which is 1.
Yes. I haven't ever done this before because I'm taking calculus next year in
No
11th
problem.
standard.
But it is, I understand. I understand you have not, you have never done it before, but still it's not difficult. Simply, I'm saying n x power n minus 1, nothing. Only 1 point,
Yes.
right? Only 1 extra point I'm telling. N x power n minus 1. Whatever constant we keep aside. So this one is going to be 27 into 2, 54, x power 2 minus 1, so x. And this is
Yes.
36 with 36. And the differentiation of x is 1. We already said here. So that's it, into 1. And that is the constant, so 0. So answer is going to be 54x minus 36. So what I suggest to you here is, of course, you are getting some idea here. Do some more research, watch YouTube, how to do the derivative. They have given so many things. You just see for x power n. Don't see for many things because that is unlimited. It will never end. So here we need only for. So in this graph, you can see this one. Yeah. So this is telling very clearly where function is going to decrease and where function is going to increase. You see in this, I told you, you find f dash x wherever it is greater than 0, this is the increasing range. Wherever it is less than 0, it is the decreasing range. And wherever it is 0, so function is neither increasing nor decreasing. It's like constant. So this is the graph of the functions. This is the function f. So this is the graph of the functions. Graph of functions. So f dash x greater than 0, increasing region. F dash x less than, decreasing region. No change, constant region. Right?
Yes.
So I'll stop the class here. I could understand so many things are going beyond. So next class, I'll continue from here. I will send this presentation to you. In fact, I will send 2 presentations. What you can do here is you need to do only those problems, which problem we have already discussed, what I'm trying to say about the parabola and all, whatever we discussed. And there are many problems based on that. You try that problems. This increasing, decreasing domain range will continue in the next class. There are many things to do. If you see the slides, we have, another, many more than 60 slides we have. So,
Yes.
okay. So, I'm going to stop the class here.